Hello everyone, this is Rishabh Kumar Saini, and today I will be discussing about my summer project which I did in IT Roorkee. My project topic is designing a particle swarm optimization based routing protocol in wireless sensor networks. Before we start discussing the project, let's first understand what is a wireless sensor network. The first wireless sensor network was sound surveillance system developed by the United States military to detect and track Soviet submarines in the year 1950s. However, the use at that time was limited to the Defense Department because of the high cost and size. Recent advantages in semiconductor, networking, and material science technologies, however, have driven large scale deployment of wireless sensor networks. Today's state of the art wireless sensor networks have lower deployment and maintenance costs, last longer, and are more rugged. They are finding their ways into numerous applications in our homes, workplaces, and beyond, bringing new sources of innovation, control, and convenience to our personal and professional lives. The main challenges of a wireless sensor network is that unlike a wired network which have full-time power supply and huge memory and processing power, wireless sensor nodes on the other hand have limited energy, memory and processing power because they have to be cheap to be deployed at so many places. Most of the widely popular MAC layer routing protocols adapt a greedy approach towards finding the best connection, which fails to provide an optimal solution in certain topologies. The suggested protocol here looks at all the feasible connections and selects the best one, hence providing us the most optimal connections in a wide variety of topologies, which will drastically improve network efficiency. The design protocol is divided into three phases. In the first phase, that is, the network discovery phase, all the nodes of the network transmit the following information to the base station. First, the list of the neighbor nodes with their connection strengths, that is, their RSSI values. Second, the energy left in the node. The base station, which is now equipped with the network information, runs the PSO algorithm for the desired source destination problem. This is the most significant phase and requires the most code. All the work in this phase is done by the base station. Hence, all the other nodes can go to sleep. Now I will explain the working of the PSO. First of all, P particles are taken and for each, the position and velocity vectors, which are both n-dimensional, are assigned random values. Then, a valid path is created using the position vector, and the path's fitness function is used to calculate its fitness value. If possible, that is, if the current fitness value is better than the existing personal best value, then the personal best vector and its position are updated. Similarly, if the current fitness value is better than the global best value and its position vector are updated. After that, the velocity vector is updated. This procedure is iterated for many times until and unless a strong convergence is observed, which is when almost all the particles are denoting the same path, which is actually the most optimal path. In the end is the result passing phase. As you can guess from the name, the base station results are passed to the nodes in the network for later use. The hardware and supporting software used were from WSNs, a German company providing solutions for massively distributed systems with a focus on wireless sensor networks. The hardware nodes used were called iSense Core Module 3. The supporting software included a list of softwares, but the most important ones were Eclipse for C++, which was crucial in seeing, editing, and modifying code, and iShell, through which we could upload our code to the hardware nodes.
In the end, the program was physically tested for a wide variety of topologies, and good signal strengths were discovered each time.